Very good morning, beloved students. Today I am going to discuss about the topic of sorting of the paper name programming for problem solving, and the paper code is CS201. Now the today's the main discussion topics in summary form is that at first the sorting techniques, then one example of sorting that is called bubble sorting, and finally I am going to discuss about some MCQ problems with the solutions. And here the expected outcome of the today's class is to able to understand sorting techniques. Now here I have to use the references for today's classes. The latest C book by Jashwant Kanitkar and C book by Rima Thereja, and also some NPTEL video lectures. Okay, so here at first the first part question is what is sorting and why is it needed? Now here sorting basically can be defined and arranging the unordered set of comparable that data items in order, and we will basically concentrate on sorting data that is stored in an array. Now let P be an array of n number of elements, that is P1, P2 up to Pn in memory. Now sorting P means arranging the contents of P in either increasing or decreasing order. That is, if we arrange the n number of data items in increasing order, then P1 is less than equal to P2, which is less than equal to P3, that is less than equal to P4, in this way up to less than is equal to Pn. And if we arrange the data in decreasing order, then P1 is greater than equal to P2, which is greater than equal to P3, that is greater than equal to P4, up to that P of n minus 1 is greater than equal to Pn. Now, here, basically sorting techniques is divided into two parts. One is the comparison-based sorting, and the second one is the address-based sorting. Now, in the comparison-based sorting, there are several sorting techniques are there. First one is the bubble sort, which I am going to discuss about the today's class. And next one also are the insertion sort, selection sort, merge sort, quick sort, heap sort, and the cell sort. And in the under the address-based sorting, here this is classified into two types. One is the proxmap sort, and the second one is the radix sort. Now I am going to discuss about the today's discussion topic, that is the bubble sort. Now here bubble sort can be defined as a comparison based sort by checking each adjacent pair of items in a list in turn, swapping the items if necessary, and repeating the pass through the list until no swaps are done. Suppose the list of numbers P1, P2 up to P of n is in memory. Now the bubble sort algorithm basically works in this way that here if the n number of elements are there, then total number of iteration or the comparison is required n minus 1. So in the iteration 1 or the pass 1, we have to compare P1 with P2 and arrange them in ascending order. That is, if we want to perform the ascending order sorting such that P1 is less than P2. Then compare P2 with P3 and arrange such that P2 is less than P3 and so on. Finally, we arrange P of n minus 1 and P of n. And this step involves n minus 1 comparison, during which the largest element bubbles up to its final position. So that is the main reason it is called as bubble sort. Now here the sorting is required for optimizing the time complexity, so that searching the specified item in a list or in a file is required time is optimal. Now here in the iteration 2, that is for in bubble sort, in the next iteration we have to repeat the step 1 with one less comparison, and in this case the second largest element will occupy its proper position, that is we stop after we compare and finally rearrange P of n minus 2 and P of n minus 1. So in this way up to the last iteration, that is iteration n minus 1 or pass n minus 1, we have to finally compare P1 with P2 and arrange them in such a way that P1 is less than P2, so that after completion of the n minus 1 iterations, the whole list of the items are sorted in ascending order. And if we want to perform in the descending order sorting in case of bubble sort, we have to perform just the reverse operation, and here also for n number of elements total number of iterations of the pass is required n minus 1. Now in the most of the cases, before reaching n minus 1 iterations of the passes, the list items are already sorted. Now in the next slide, I am going to discuss about one example of the bubble sort. Now let us here consider 5 number of elements, that is n equal to here 5, and the elements are 7, 2, 8, 5 and 4. And here P1 contains 7, P2 is 2, P3 is 8, P4 is 5, and finally P5 is 4. Now as n equal to 5, so total number of iterations required are n minus 1, that is 5 minus 1, which is 4. Now in the iteration 1 or the pass 1, first 2 elements, that is P1 and P2 are compared, which are already highlighted. Now as here, if we want to perform ascending order sorting, and as P1 is greater than P2 in the initial case, so we have to perform the swapping operation such that P1 is less than P2. So after swapping the 7 and 2, the items are arranged in this way. Now we have to go to the next operation under the same iteration 1 or the pass 1, that is P2 is compared with right now P3. Now P2 is 7 and P3 is 8, which are already highlighted. Now 7 is less than 8, so no need to perform the swapping operation. Now we have to compare P3 with P4, that is 8 is compared with 5. Now as 8 is greater than 5, so again we have to perform the swapping operation such that P3 is less than P4. So after performing the swapping operation, the list looks like this one. Now in the next operation, P4 is compared with P5. Now as P4 is greater than P5 initially, so again we have to perform the swapping operation in between P4 and P5 so that the largest element, that is the 8, will be placed at the last position of the list. Now here the iteration 1 is completed right now. So after completion of the iteration 1 or the pass 1, we can say that the largest element already placed at the last position of the list. So in the next iteration, no need to compare with the largest element. So in the next iteration, that is iteration 2, again we have to start it from the first 2 elements comparison operation, that is P1 here compared with P2, and as P1 is less than P2, that is 2 is less than 7, so no need to perform the swapping operation. Now we have to compare P2 with P3, and here as P2 is greater than P3, so we have to perform the swapping operation in between P2 and P3, and the list looks like this one. Now in the next operation, 7 is compared with 4, and as 7 is greater than 4, so again we have to perform the swapping operation. Now after completion of the iteration 2, we get the next largest element, which is 7. And as I told that already after completion of iteration 1 or the pass 1, the largest element here is 8. So no need to perform the comparison with the largest element. So here, after reaching this part, iteration 2 of the pass 2 is completed. Now we go to the next iteration, that is iteration 3 of the pass 3. And again, we have to repeat the same process, that is P1 is compared with P2. And as P1 is less than P2, so no need to perform the swapping operation. So we have to go to the next operation, that is P2 is compared with right now P3. Now as P2 is greater than P3, so again we have to perform the swapping operation, and the iteration 3 here is stopped because the next element is the 7, which was the next largest element of this list. Now we have to go to the next iteration, that is iteration 4. But before reaching iteration 4, although the list is sorted, but theoretically we have to also cover the iteration 4 of the pass 4. And here also we have to repeat the same process, that is P1 is compared with P2, and as P1 is less than P2, so we have to stop the operation, that is the swapping operation. So finally we have to perform the ascending order operation of the bubble sorting techniques. So in this way, the bubble sort operation here we have to perform. Now I am going to the next section, that is the notepad section, where I have to discuss some MCQ problems here. So in the notepad section, the first problem I have to write down here, that is the stability of a sorting algorithm is important for, so there are the 4 options are there. I have to write down these 4 options. Here out of these 4 options, here the correct answer is option C, That is the sorting the alphanumeric keys because they are likely to be the same. And alphanumeric keys, all of you know, that is alphabet with some numerical values. Now in the next MCQ problems, here I am going to the write down here, that is question number 2. Now in this case, here the correct option here is option A, that is n minus 1. That is the option A, here is the right one. Because worst case means if the data items arranged in ascending order and if we want to perform the descending order sorting, then it is considered as the worst case because here time complexity is highest in optimum sense. Okay. And in the reverse operation of the worst case is best case. So if n number of elements are there, so obviously in worst case, total number of comparisons here is n minus 1. Now I am going to discuss about today's last MCQ problem, that is question number 3. So the question number 3 is basically the problem is sorting is not useful for, so there are the 4 options. Now out of these 4 options, here the correct answer is option B, that is minimizing the storage needed, right? So I have to stop my today's class. Thank you very much.